Hey everyone, and welcome to today's Explainer. We're going to be diving deep into the architecture of Java today. We're talking about building from the absolute ground up, all the way to the massive revolution that was JDK 8. Now, if you write code, you already know nothing stands still, right? Languages are always evolving. And really, mastering the core blueprint is the only way to effectively leverage those advanced features that are pushing our entire profession forward. Let's get into it. So here's our roadmap for this explainer. We'll start with the foundation of Java, move into adding action with methods, then building with constructors, managing memory and garbage, and we'll wrap it all up with the Java 8 revolution.
Starting off with Section 1, the foundation of Java.
At the very heart of it all, we have the class. You can think of a class as the ultimate template. It encapsulates both your data, so your instance variables, and the actual code that operates on that data. Literally, any concept you want to implement in Java has to live inside one of these classes. It is the core logical framework that the entire language is built upon.
A really great way to visualize this is to think of a class purely as an architectural blueprint. It's just like those lines on an architect's desk before a building is actually constructed. It defines exactly what the structure is going to look like and how all the different parts relate to each other. But, and this is key, it doesn't create a physical reality all on its own.
So to clear up a super common point of confusion, think about that logical template compared to the physical reality. The class is just the idea, right? The object is the actual physical reality taking up real estate in your memory. You bring that reality to life by using the new operator, which dynamically allocates that memory right at runtime. So again, the class is your template and the object is your living, breathing instance. Let's move on to Section 2, adding action with methods.
Now, in a well-designed Java program, you rarely just expose your internal data to the outside world. That is a recipe for disaster. Instead, you use methods. These are essentially Java's subroutines, and they securely access and manipulate your data. Methods define the interface to a class, basically hiding all those messy internal data structures behind clean, simple abstractions. This is huge because it means you can completely change the internal workings later on without breaking things outside the class.
But that brings up a really good question. How do we make these methods flexible? Like, what if we want a method to operate on a bunch of different data instead of just being hard-coded? Imagine a method that calculates the volume of a 10 by 10 box. Wouldn't we rather it calculate the volume of literally any box?
The secret here comes down to understanding parameters versus arguments. So parameters are basically empty slots in your method's definition, just waiting to receive a value. Arguments, on the other hand, are the actual concrete values you plug into those slots when you run the code. Keeping that distinction clear in your head is absolutely foundational to mastering Java.
Okay, on to Section 3, building with constructors. So instead of manually setting every single variable one by one using external methods, a constructor does all that heavy lifting the exact moment you use the new operator. It automatically initializes the object for you, it uses the exact same name as the class, and uniquely, it doesn't require any return type at all, not even void. It just makes sure your code gets a fully initialized, ready-to-use object right out of the gate. Pretty handy, right? But things can get a little tricky. What happens when a local parameter name collides with an instance variable name? Like, say your parameter is named width, and your instance variable is also named width. To fix this, you use the this keyword. It acts as a direct reference back to the current object. By just typing this.width, you're telling the compiler exactly which variable you're actually talking about.
Moving right along to Section 4, managing memory and garbage.
Since we're dynamically allocating memory every single time we create an object, how does that memory eventually get released? Now, if you're coming from a language like C++, you know all about manually destroying objects. But Java takes a completely different approach. It actually handles the deallocation for you.
Java has this amazing built-in janitor called garbage collection. It quietly works in the background, recycling memory for objects that your program just isn't looking at anymore. Basically, when there are no more references to an object, the system just assumes, hey, we don't need this, and it reclaims that memory automatically. It's totally hands-off. I do need to give you a massive warning here, though. While Java does offer a finalize method for last-minute resource cleanup, like maybe freeing up a file handle, you can never, ever know when or even if it's actually going to run. It doesn't just trigger the second an object goes out of scope. So please absolutely never rely on it for critical operations or your normal program flow. It is completely unpredictable.
And finally, Section 5, the Java 8 revolution. Now, the release of JDK 8 was a real game changer. It fundamentally changed the way programmers write code. We're not talking about a minor patch here. It massively expanded the scope, the power, and the range of Java, essentially pushing the whole profession forward into a much more dynamic and demanding era.
This update brought us 3 standout features that finally added functional programming capabilities to Java and vastly improved library handling. We call them the Big 3: Lambda expressions, the Stream API, and default interface methods.
Lambda expressions are, without a doubt, one of the most important features of JDK 8. Imagine taking that clunky, multi-line anonymous class code, which you used to need just to handle a simple button press, and condensing it into a single beautiful line of executable logic using the new arrow operator. It radically cuts down on boilerplate and makes passing executable logic as an argument an absolute breeze.
Next up, we have the Stream API. This allows you to take massive sequences of data and efficiently process them through pipelines that can search, filter, and map that data. And honestly, the best part? It can often do all of this in parallel. That gives you a massive boost in efficiency and speed when you're dealing with really large data sets. And finally, default methods. These solved a huge historical headache for developers. Back in the day, if you added a new method to a popular interface, it broke literally all the existing code that used it, because those older classes didn't have an implementation for the new method. Well, default methods fix that by letting interfaces supply a default implementation. This allows them to gracefully evolve over time without completely wrecking all your pre-existing code.
So, as we wrap up today's explainer, I want to leave you with a thought. In a highly competitive programming world where change is literally the only constant, are you really ready to adopt these new strategies? Java threw out a lot of old techniques and replaced them with vastly more powerful tools in JDK 8. Mastering these concepts, from the basic blueprint of a class all the way to the elegance of a Lambda expression, is exactly what separates the great programmers from the rest. Thanks so much for exploring the architecture of Java with me.